She
Mhm.
said she would rather suffer than wear her socks. We were like, well, that does not mean this is a very good solution. That was a turning point for me, understanding that there was a true fundamental gap in the care that we're able to provide amputees today.
Today's guest is tackling one of the most fundamental and overlooked problems in prosthetics: the fact that people's legs change size, but their sockets don't. Cindy Robinson is the co-founder and CEO of Vessel Prosthetics, where she and her team have developed the KIN system, a purely mechanical, self-adjusting prosthetic socket that automatically adapts as amputees move. Cindy's background is in engineering and human motion research, and during her medical innovation fellowship at Western University, she spent time in a diabetes clinic where she kept meeting amputees whose solution for a bad fit was stopping their day to add layer after layer of socks. One woman even told her that she would rather suffer than wear them. That moment helped spark Vessel. Today we're going to dig into how the KIN system works, what it means for patients, and how a simple, elegant mechanical idea can change access to prosthetic care. Sydney, welcome to the show. What's your story?
Yeah, so my story is that I have always been fascinated with the human body. I love the way that it moves. I love how many different things we can accomplish with the body. I remember learning really early on that the knee joint is smoother than two pieces of ice sliding against each other, coefficient of friction. Um, and you're standing on two of those. I was like, that's impossible. Like, there's no way. That's so cool. So when I was choosing which college in Canada, which university to go to, I was choosing whether I would want to do engineering or kinesiology. And I ended up choosing engineering, which I'm really grateful for. But that was really where my journey started was, okay, I'm good at math and science. Engineering is the intersection of those two. And I love the human body. I'm very passionate about it. And prosthetics marries engineering with the study of human motion.
So then you went to Queen's University for your undergrad, and then your master's was at Western University. And that sounds like a very interesting experience. Can you talk more about that?
Yeah, absolutely. I did some research in between my undergraduate years. So between second and then third and fourth year, I was doing research back home in London, Ontario at Western University. And I was working with a couple of researchers here. We were working at the time on a study funded by the Arthritis Society that was looking at the amount of force that you have to put into your fingers in order to do different tasks of daily living, which is really interesting. I don't think a lot of people think about the amount of pinch and grip strength that it takes just to do daily tasks. So we looked at, cutting vegetables and turning knobs and unscrewing a water bottle cap. And it was really interesting to me to see how you can identify a problem in real life and then research what's being affected by that problem in the human body and then go so far as to think about ways that maybe we could help or we could solve that problem. So my research, once I signed on to do my master's, was a continuation in part of that type of research. So we were looking at wrist motion instead of finger motion, and we were looking at the difference between healthy and injured wrists and just how that can affect activities of daily living. But also we were using four-dimensional computed tomography, or 4DCT, to basically get a video of your bones moving relative to one another as you moved your wrist, which was super cool. And so we used that then to diagnose different issues with an injured wrist versus a healthy wrist, and basically
Okay.
just to codify how the wrist actually moves. I was using it as a way to influence or inform the design of a novel wrist implant. Because of COVID, I didn't get to actually move forward with that part of the project. We focused on other areas, but it was a really great way for me to continue doing research, which was something that I loved. I didn't love it quite enough to do a PhD, but that was then what led me to do the Medical Innovation Fellowship at Western as well.
Okay. Okay. So then I guess in a layman's terms, what problem are you guys solving for amputees today at Vessel? And how is the self-adjusting socket helping these patients?
Yeah, this was something early on in the business we really had to define because, as you can imagine, not everybody has a leg amputation and not everybody knows someone with a leg amputation. So, the easiest way that I can put it for able bodied folks like you and I is we've all worn shoes that don't fit. And if your shoes don't fit and your feet slip around inside your shoe, you can get a blister. that blister is not only painful, it can also get infected. And this is happening to people, but it's with their leg. So a human body will change size throughout the day and in the long term from diet, exercise, weight fluctuations, even the seasons, especially here in Canada. And all of that change means that your body is dynamic, constantly shifting its size. But a prosthetic leg, although it's custom, is static. So it's made once and that's its size. And so that can be really frustrating for the issues I mentioned with the shoe. If the leg changes size inside of a prosthetic socket that does not, it doesn't fit well, just like a poor fitting shoe, and you can get blisters and infections. Unfortunately, for people with leg amputations, they can also get another amputation further up the leg because of those infections, or if a wound isn't healing properly. And the best solution that people have today is to use socks. So sticking with the shoe analogy, your shoe doesn't fit. You really loved the way they looked, but they're too big. So you put on 4 pairs of socks to make your feet fit. And that is the high-tech solution that we've got people using right now is, stop whatever they're doing, whether they're at their grocery store, their daughter's soccer practice, just out for a walk. They have to find somewhere to stop, take their prosthetic leg off, and put a sock on to try and accommodate for that changing leg size.
Yeah, that doesn't sound very sophisticated.
No, it was amazing when we learned about it because there's so much cool new technology out there today, especially in prosthetics as well. Like there's a lot of really amazing, I'm sure you've heard of like myoelectric hands or an electric knee joint, an electric ankle. Like there's all this super cool technology. And yet the socket, which is the part that connects you to your prosthetic leg, has not been innovated in so long. And so when we were looking at the problem, we identified that, okay, there's socks, which is still the gold standard. There's a few adjustable sockets on the market, which is fantastic, works really well for some patients to have a dial or a ratchet strap that they can adjust on their own. So they're, on the fly, making those adjustments. But there's a big group of people with leg amputations or limb difference that find it very difficult to make those changes on their own, whether they don't have any feeling in their leg, which obviously makes it very difficult to know how to affect the changing size of the socket, or if they have a cognitive impairment, maybe they're part of the aging population and it's difficult to remember to make those changes or difficult to know how to make those changes. All of these kinds of impairments mean that a prosthetist or a prosthetic technician would like to use an adjustable socket, but maybe can't rely on the amputee to make those changes on their own. And so what we wanted to create was a way for the prosthetic leg to automatically adapt to changes in the anatomical leg size, regardless of what the amputee is doing. And so that removes a lot of mental burden from the amputee, and it removes a lot of frustration for the prosthetist.
Okay, very cool. So from what I'm hearing, it sounds like you guys are solving a very fundamental problem in the field, in this specific space and niche. I want to ask more about jumping back to your fellowship. How did you guys find the need?
Yeah, so we were shadowing a doctor at a diabetes clinic. And with diabetes being the leading cause of leg amputation, we met a lot of people that day that had leg amputations. And it was amazing to us because the number one reason why they were in the clinic was because their prosthetic leg didn't fit properly. And we watched how debilitating that was for the amputee, right? They weren't able to do a lot of the activities that really mattered to them. But it was also super frustrating for the clinicians. Like you saw them run back and forth. They're trying to, okay, what if I put a pad in here? Does that feel better? No, the pressure is still over here. Okay, what if I make the pad a little bit smaller? Now is it better? And it was this guess and check work. We're like, man, it would be so nice if the socket just adapted on its own. And that was really where it all started.
That sounds like a really cool experience and also very, I guess, fundamental to the formation of the company as well.
Very much so, yes.
So then, was there a particular patient story that kind of best captures why you guys felt that the KIN system is so important to be a thing?
That's such a good question. There are so many stories. I feel like every time I connect with a patient and they tell me their story, I'm like, I'm so excited to help. But there was one woman specifically, we didn't have a solution. We were just learning about, how do you use socks? How do you use your prosthesis? Tell me about a day in the life. Just trying to get a better picture of what it's like to use a prosthetic leg because everyone on the team is able-bodied. And we really wanted to know that user experience. And she said she would rather suffer than wear her socks. We were like, well, that does not mean that this is a very good solution. And so we just knew that was a turning point for me, understanding that there was a true fundamental gap in the care that we're able to provide amputees today.
Yeah. That sounds like really solid validation. So I want to ask, Sydney, did you always know that you wanted to start your own company?
No, I did not. I I'm the oldest of 3, and I'm very type A. I'm the definition of an extrovert. So grandparents would be like, "One day you'll own your own company." But I didn't really feel that on an emotional or fundamental level. It was not my goal whatsoever. If anything, when I did the Medical Innovation Fellowship, whose whole job is to teach you how to start a company, I thought that maybe this would work well for me. Maybe it would be something I'd be interested in. And I might as well learn now because I have a flexible life stage that I'm in, and it would be nice to learn what entrepreneurship is like. And then it was really the problem and how opportunistic that problem was, and how important that problem was, and how well connected we were to the patients and to the prosthetists. I was like, oh, it would be a shame if I didn't at least try. I think we have a very clear idea of how big and debilitating this problem is. And I would just love to be able to bring something to the market that could help.
I love that.
Thank you.
Okay, so then take me from your 0 to 100. We have you and your innovation fellowship, and we have the company now. How did this all happen?
A good question. Sometimes I ask myself. So it's been almost 4 years. So the first year was just me and my co founder. We were doing pitch competitions, grants, incubators, anything to get some funding into the company so that we could continue to prototype. And we were doing a lot of incubator programs that taught fundamental skills of how to start the company. The Medical Innovation Fellowship gave us a solid foundation, but a lot of these programs specialize in something like marketing or sales or branding or pricing strategy or something. And so we were taking all of this information and using it to really create a solid foundation for the company, for Vessel. And then we were able to hire on our first full-time employee, who is an engineer, about a year after the company started. He's still with us today, which is super exciting. And then it was just us 3 amigos for a while. And I moved down to Texas for 3 months. We did the Techstars Physical Health Fort Worth Accelerator while the team was prototyping at home. I was down there trying to build relationships. The theme of 2024 was fundraising. So I was fundraising, doing our pre-seed round, which was $1 million US was our goal. We've oversubscribed, which was very exciting. And then in 2025, really the company kind of exploded in growth, honestly. The capital is a fuel that a startup company needs, especially a medical innovation type company. And so we used that funding to hire a lot more team members, then also work with strategic consultants and actually do a ton more prototyping. And so now we are getting ready to actually launch our product on the market.
Very exciting. Okay, so two follow-up questions from that then. How did you meet your co-founder? Was that through the innovation fellowship?
It was, thank heaven, because people will ask, like, how did you meet your co-founder? Do you have any tips on how to find a good co-founder? And we were so lucky because we bonded day one during the fellowship program. We got along like a house on fire. And so we bonded first as friends, but we also worked together as colleagues. And so what was nice about that was it wasn't like we were two best buddies from elementary school that were starting a company together and didn't really know how it would be working together. We knew that we could maintain a friendship and work together at the same time, which was fantastic. And then we also knew from working together that we liked to work on different things, which was also really helpful. It's not like both of us wanted to do the presentations or both of us wanted to do the prototyping. We were able to divide and conquer, which was really helpful.
Yeah. Yeah, I've heard in like businesses, it's always good for each person to have their own track and their own domain and ownership over different parts of the business. So,
Absolutely. I think, early on, we both tried to do everything a little bit, and that just gets very confusing.
Mhm.
Who's owning what, who's following up on what. Whereas now we know exactly who is going to take ownership over what thing. And we know that each person, obviously, you have jobs you don't exactly want to do. But for the most part, we can show up to work each day motivated, excited to get to work because we get to work on elements of the business that we're really passionate about.
mhm. And then the second follow-up question, when did you guys have your first prototype? What did that prototype look like?
That's a good question. And it's a little bit hard to answer because of the definition of the word prototype. The very first time we had a prototype, we had not incorporated the company. We were in the Medical Innovation Fellowship, and we had a design in mind for like a hydraulic system. So using liquid, we didn't know what kind, but we were using water in our prototype in order to move pressure around the leg. So we had these remoldable beads that we molded onto my leg as plates that fit my leg shape. And we used like these little bladders that we bought online, and we like hooked them up with tubing just to show that the general concept would work. So that was technically the first prototype. It looks like a high school, no, like an elementary school science fair project gone wrong is what it looked like. But it proved the thesis and the concept would work. So then we graduated and we did like some physical prototyping, but nothing super sophisticated. And then what really helped level us up was we created our own leg, our own limb. And the limb we created, we could use electronics and a motor to expand and contract the volume of the leg in order to simulate that. And then we put that inside of a motion simulator in order to simulate walking so that as the person walked, their limb volume decreased. And we could use pressure sensors to see how our system would be able to respond to that change. So that was like the first good prototype. I don't know what to label that one, but it was really helpful to have like a leg that we could kind of prototype on. So that was the first more legit, I really don't know what to call it, more legit prototype. And then the next level up from that was in August of 2024. Stevie Crawford, our patient model, tried it on for the first time. So it was the first time a person wore it. And I will never forget that because that was really incredible.
Very cool. Okay, so let's talk more about the technology. Can you walk us through kind of the full force path of what's happening from the ground up when the user takes a step to the shock absorber and then the volume adjustment?
Yeah, absolutely. I've got a prop, so I'll talk through it
Oh,
if people are just listening, but I'll also kind of walk through it, no pun intended, with the device here. So this is a 3D printed version because we could make that at home, but a prosthetist would typically laminate this with carbon fiber. So the way that our device works is this is the kin system down here at the bottom. What it's doing is as someone walks, this part right here is shock absorbing. So it's compressing. It's using walking motion as its power source. And that walking motion is turning this dial. Right now it's too tight to turn, but it's turning this dial automatically and pulling these panels in against the leg because this dial has a spool. Wrapped around the spool is the cable, and the cable comes down into this unit. So it's in here in the spool, comes out and around and hugs these panels in against the leg. It only does that to a set level of tension. So what it's doing, it's not monitoring anything because there's no electronics, but it will twist the dial and it will tighten until it reaches a certain level of tension, and then it won't go beyond that. So every time someone takes a step, it's deciding if it needs to tighten or maintain its current size. And that's purely based on the tension that's in the cable and therefore the compression of the panels against the limb. So it automatically constricts based on the volume of the patient's leg. And then that manual button you saw me push is just a button to release the tension in the cables if the leg has swollen.
okay. Does it go the opposite way? Like, does it loosen?
At this point, it just tightens. The reason for that is twofold. First, we had to start somewhere. And second, the reason we chose constriction is because typically people's legs will shrink throughout the day. So as you put this continuous pressure all around the leg as someone's up and moving and they have their prosthesis on, you're pushing fluid out of the limb. So swelling, edema, the fluid is being pushed gradually out of the leg. And so typically the leg will shrink as the day goes on. And so we wanted to be able to automatically accommodate that. But sometimes your leg also does swell. And usually that happens when fluid is able to pool in the leg. So if I'm sitting at my desk for hours, which I am, my leg might swell. Or if I got on an airplane and because of the altitude, my leg would probably swell. And so that's why we have that manual push button release is you hit the release button on the side, it relaxes the tension in the cable. And then as soon as you stand back up, the system will re-engage and adjust to the new volume of your leg.
Makes sense. The system does not have any electronics. So how is it distinguishing different movements? Like, for example, if you accidentally like tripped on something, would that tighten the kin
That's a good
system?
question. So because it can only tighten up to a certain tension limit, even higher impact activities don't let it go beyond what it's able to do. So it can't tighten any further than what that limit is, which is intentional. So that, as you're saying, if you are jumping or stepping out of the way of a moving vehicle or something, it's not choking your leg.
That's good risk mitigation.
Yeah, absolutely.
So you also, on one of the blog posts that I read, talked about volume management versus vacuum. So I wanted to get into like how do those two things work together? And for people who don't have context on those two things, can we also explain that a little bit?
Yeah, for sure. They go hand in hand, the two explanations. So I really appreciate you doing that research and also bringing it up because this is a question I get all the time. So the fundamental difference is there's a suspension system, which is how your leg is connected to your prosthetic leg, how you actually keep the prosthetic leg on. That's a suspension system. And then there's a volume management system. So this is the way that you are managing how your leg is changing volume. A suspension system, one of the options is a vacuum system. So literally vacuum sucking your leg down into the prosthetic. What's really nice about that is for some patients that experience a little bit of limb volume fluctuation, vacuum has actually been shown to maintain a very consistent level of volume. What it does is it's pulling the skin against the walls of the socket. It's maintaining really great circulation of the blood through the leg, and it's able to kind of keep the skin out and keep a very stable limb volume. So for certain patients, that works really well. There are some patients that either experience too much limb volume change, where the vacuum just can't really accommodate for that, or they can't use vacuum for some other reason. Some people just don't like the sensation. Some people have other contraindications that make it difficult to access that type of suspension system. So there's other ways for them to connect their anatomical leg to their prosthetic leg. Our system is not a suspension system. So you do need to connect your leg to your prosthetic leg, either using suction or using what's called a pin lock system. Our system is an adjustable socket system. So what it does is it is accommodating for changes in limb volume. It's not trying to maintain a consistent amount of limb volume. As the limb volume changes, it's accommodating for that change. So where our system accommodates for change, a vacuum system tries to maintain a consistent size.
So if we were to like kind of diagram this out, this is like the patient's leg, and then you have the kin system, and then you have the prosthesis below that.
Yes, correct.
Talking more about the kin system, it uses kinetic energy and this mechanical adaptation mechanism, which sounds very technically complex. So, what technical insight do y'all have that no one could really replicate?
I think what sets our team apart is our dedication to user-centered design, which I'm sure everybody in engineering talks about nowadays. But what is tempting is to look at AI and automated systems and mechatronics and robotics and try and create this really high-tech Iron Man type leg that can automatically adapt. And that's great. The problem with that is that patients can't always access those solutions. The majority of people with leg amputations are part of the aging population. They're part of lower socioeconomic status. The statistics around the population that we're looking at means that maybe they don't have access to a power source to charge their leg at night. Or maybe it's easy to forget to charge your leg at night, as it is for me to plug my phone in at night. Anyone can forget. And so what we wanted with our design was to make it as accessible as possible, both for the patient, like I just described, but also for the prosthetist. A prosthetist, if someone comes in with a problem, wants to be able to diagnose the problem and fix it while the person is there in the clinic. They don't want to have to become electrical engineers just to figure out what's wrong with their Iron Man leg. Instead, keeping things mechanical allows it to be as field serviceable as possible. So this empowers the prosthetist to help the patient if they ever had an issue right there on the spot. And so really for us, the technical insight that we had was creating a simple, elegant solution. How can we enable automatic adjustment in a purely mechanical way?
Yeah. Sydney, I think you bring up a really good point because when we think about other industries, like for example, like in cardiology, you have entire device clinics with reps who need to be there all day to troubleshoot the devices, and it's not easy to deal with. So simple is better in a lot of ways.
Absolutely.
So then let's talk about technical challenges. What was the hardest part? And I know you also spoke about like creating a phantom model in the earlier stages. I feel like that's something that doesn't come to mind right away, but having worked on devices like how you described in the past. I know creating a phantom can also be a whole engineering project on its own. But yeah, tell me more, speak to more of the technical challenges that you guys have overcome.
For sure. Simple, elegant design is great, but making it small enough that someone wants to put it on their leg is a totally different constraint and challenge. And I think that's been our team's biggest challenge to date has been, okay, here's all the amazing features we want this to have. Here's the torque advantage that we want and the automatic adjustment and all of these different elements and how strong it needs to be and how durable it needs to be and this, that. But it also has to be as light and as small as humanly possible. The ideal weight of a prosthetic leg is 0 pounds. The ideal weight is like invisible, non existent, which is very counterintuitive. When I tell engineers this that are outside of the field, they're like, well, my leg weighs, 20 pounds or 30 pounds or however much my leg weighs. Isn't that how much a prosthesis would weigh? And the reason that it's not that is because your leg is working for its ability to be there. Your leg is fully connected. It's using its muscles and ligaments and tendons to help deliver energy to your body. And it's working for its opportunity to be there. Whereas a prosthetic leg is not. A prosthetic leg, no matter how well connected it is, obviously better connection is better performance, but any prosthetic leg is still dead weight, just sort of hanging off of the leg. Yes, we have a lot of great technology nowadays that can offer more energy return, but it's still not the same as an anatomical leg. And so for our system, when we wanted to add all of these amazing features and components, it does have some weight to it. And so that was the biggest challenge, was trying to get it to be small and lightweight enough that it can be used by patients in a way that is comfortable.
Okay. When I was looking at the website for Vessel, I saw that there is a page that has the technical specifications. So for engineers who are listening, can you point out, I guess, like maybe the highlights of that?
Sure, yeah, absolutely. So our device, I keep talking about weight. Our device weighs 1 pound, definitely something that we're looking to minimize as much as we can, but we're very proud of that kind of first weight. The amount of weight that it can withstand in terms of patient weight is 275 pounds, and it does have a height of about 2.3 inches. So there's different prosthetic components that come underneath of the socket, underneath of the anatomical leg, that connect the anatomical leg or the prosthetic socket down to the foot component. And so our piece sits in that range and it adds about 2 inches of build height. One other interesting fact is that it has 6 millimeters of compression, up to 6 millimeters of compression. And when we say up to, it's because depending on the patient's weight, we have 3 weight categories, and whether they're at the high end or low end of each weight category dictates how much they're going to compress the shock absorber. It doesn't really matter because any amount of compression can lead to an automatic change in the system if an automatic change is warranted, i.e., if the leg has shrunk. But it is something to consider in terms of what the patient will feel as they're using the system.
Is there a way that the prostheticist would adjust those limits based on the patient's weight?
Yeah, so a couple of things that they keep in mind in terms of the shock absorber. If you have a patient who's highly active, they might like a little bit of a stiffer feel. So especially if they're on the cusp between weight categories, you can easily choose the softer or more firm shock absorber to kind of fit each patient's individual needs. And then some people, regardless of activity level, also prefer one over the other. They prefer it to feel softer or more firm. So you can customize based on what the patient's preference is. The other
Very
thing that
cool.
you're able to customize is that amount of tension in the system. So the amount of compression that someone would feel. Some people like a really snug fit. Like they want those panels to really push in against the leg, really hold them in because they like the stability that comes with that. Other patients don't want quite so much compression, or they might have other comorbidities like peripheral artery disease or something that means they're not quite as tolerant of that high level of compression. And so the prosthetist is able to customize patient to patient what would be a good fit for them and fit literally in terms of amount of compression on the leg.
Okay. You brought up comorbidities. What are some of the common disease states that are interfacing with what you guys are doing?
There's a lot, actually. It's a very challenging space to work within as a prosthetist for that reason. So, some of the things that people experience would be diabetes. Diabetes is the leading cause of leg amputation. So, about 70%, give or take, of leg amputations are because of diabetes. Another thing that people will experience would be peripheral artery disease. So very similar. And then amputation actually can lead to other cardiovascular diseases such as hypertension. So that can be something that people are maintaining or monitoring. A lot of patients that have leg amputations are heavier. They tend to be more overweight. And so that can be something, not necessarily a comorbidity, but a lifestyle or a factor when you're talking about the different kinds of care that people will need. And then people are also part of the aging population most often. So most amputees are over the age of 65. And so that just means that sometimes cognitive or memory challenges can also come into play. Dexterity is a big one as well. So when I was mentioning those manual solutions that require the use of a dial or a ratchet strap, it can be very difficult for some amputees to actually use their digits, their hands, or their fingers to make those adjustments on their own. And then if people have multiple amputations, for example, missing both of their hands and both of their legs, that can be another dexterity impairment that makes it difficult to manage prostheses on their own.
So far in this conversation, we've talked about a lot of different stakeholders. Who is your customer? Is it the prosthetist? Is it the clinic? Is it the amputee? Or is it insurance?
We work directly with clinicians. So we work directly with the prosthetist. It's a business to business transaction. So we sell to the clinic and then the clinic sells to the amputee. The prosthetist is the one who knows best who's going to be a good fit for our system based on all of the things that we've talked about so far: comorbidities, use cases, length of their limb, activity level, goals, age, weight, etc. And so they're the ones that are really driving the ship in terms of which patients would be a great fit for this system. And then they do require prior authorization from that patient's insurance company. So insurance is definitely, payers are definitely involved in the process, but our customer is the prosthetist themselves.
How does the KIN system fit into the existing prosthetics workflows right now?
That was another thing when talking about user-centered design, not only users like amputees, but also users like prosthetists. We were very cognizant of the fact that we would want it to be as usable as possible by the prosthetist. And one of those things to consider is, how does it integrate into their current workflow? And so right now, prosthetists typically laminate a prosthetic socket using sheets of carbon fiber, and our device can be laminated directly into that. So we use very similar measurements for our lamination plate as other lamination plates that are available. And then we've also created a different attachment mechanism that is called a 4-hole adapter. So there's a couple different ways that you can attach pieces to the bottom of a socket. One is by laminating it directly in, which is one of our offerings. And then one is kind of bolting something to the bottom, which is the other version that we offer. So we've tried to offer as many different versions as possible so that prosthetists can pick and choose what works for them. And then the other thing that we've actually considered is working with central fabrication sites. So as companies and clinics are scaling, they're opening clinic locations in multiple places, but those new clinic locations don't have a lab in the back. Typically, the lab in the back room is where you build the prosthetic legs. So that's where you're laminating with sheets of carbon fiber and things like that. Newer clinics don't always have those. And so what they'll do instead is they'll have one central location that does all the fabrication, a central fabrication site, and they will do all the patient care in their clinic, and then they'll just send the measurements of those legs to the central fabrication site, which makes the socket and ships it back. And so we are partnering with those kinds of clinics, those central fabrication sites, in order to train them on how our system is a little bit different to fabricate. It still fits within the workflow, but a little bit different. And so we've been educating them so that they can best support the clinics that they work with as well.
This almost reminds me of kind of like a central lab, like if you have different samples and stuff. Yeah, that's very cool though.
Exactly.
Okay. So then I guess in terms of like where this fits into the market, it's kind of creating, like you said, there's existing products that kind of work on this adjustable socket situation. But you guys are creating kind of a new thing in the space. How do you see this like kind of expanding the market, or do you see it reaching new patient populations that weren't able to participate before?
Absolutely. I keep getting this big smile on my face because I'm so excited about it. But yeah, no, there's definitely patient populations that we think are being underserved now that our device helps prosthetists to serve better. So there's actually a lot of individuals that live in rural communities hours away from a prosthetic clinic. So you can imagine how frustrating it is if you have something wrong with your prosthesis and you have to drive like 2 hours to get to the clinic, have the hour clinic appointment, and drive 2 hours home. Or that's not even including the time you would have to take off work. What if you're working? Now you have to take a day off work just to go into the prosthetic clinic. And so there's actually a high abandonment rate or a high rate of individuals that just stop using their prosthesis and have to use a wheelchair instead. And that's fine if that's a choice that you need to make for, comorbidities or the best of your health. But if the only reason that you're doing that is because you aren't able to access proper care, we think that that is a problem. There's also folks like indigenous populations that are, on reserves, maybe live further away from clinics, once again, in more of those rural communities. And so we'd love to be able to help those types of individuals. And then with all of the different wars that are happening right now worldwide, we really want to be able to help war-torn countries as well that are being burdened by the number of amputees, both civilians and military personnel. And so with something that can automatically adapt, you're reducing the number of times patients have to come in for follow-up, which actually frees up clinicians' time to then help more patients.
Yeah. Yeah, and definitely the fact that it doesn't have any electronics makes it more accessible for all these populations that you're talking about.
Exactly. Yes, that was one of the goals.
Yeah, run me back for a second. What exactly is lamination?
Great question. So the way that prosthetists make prosthetic legs traditionally is through lamination. What they're doing is they basically cast your leg, kind of like if you broke your leg. So they'll cast it, they fill that cast with plaster to make a positive mold of your leg. And then they will take sheets of carbon fiber and they will place them over top of that mold. They will pour resin into that and vacuum seal it against the mold of your leg. And then once that hardens, they can take all of it off, sand it down, and now you have a custom fabricated or custom laminated carbon fiber prosthetic socket.
Very cool. I did not know that that is what that looked like.
It is wild. It's really cool to see. There's so much of it that's based on experience too, like the amount of how much resin am I going to put in, and how many sheets of carbon fiber, and in what orientation, and it's amazing to watch prosthetists work because there's so much of it that is learned on the job.
Yeah, it sounds like kind of a scientific art in some ways.
It is definitely a combination of the two. I feel like I chatted with a prosthetist cast, and she was saying, we take inspiration from all these different places, right? We take inspiration from like the movie and arts industry in order to make prosthetic covers that look realistic. We take they're like mechanics, right? They're working so much with their hands to problem solve and put different components together that would work together in certain ways. And it's amazing what prosthetists are able to accomplish.
Yeah. So then you kind of spoke a little bit about the business model. What does that look like over time? Like, is there going to be like some sort of subscription device? Like, is it going to be device sales per patient fees? Like, how is that going to work?
Great question. So it is a one-time device fee. So per patient, they typically will replace their sockets on average every 2.3 years. So we are able to sell multiple devices to one patient, but it's a one-time fee upfront.
You've talked a little bit about your first patient finally getting to put the system on. How many people are using the KIN system right now?
We've got about a dozen that have either tried it as part of our patient trials or are starting to do kind of early pilot sales with the system. So we're very excited. It always is funny because compared to one person, it seems like so many people. And then compared to the numbers of patients that we would like to help in the future, we really are just getting started.
What did the process for that look like? Do you have to go through IRB and things like that?
So in terms of the user feedback, we're a class 1 medical device. So the class 1 medical device, certainly you need to have all of your ducks in a row when it comes to like a research project that you're doing with academia. But when it comes to user feedback in terms of giving feedback on the device, as long as the manufacturer, the company, has their quality controls in place and is doing a good job of maintaining those, it's pretty easy to get feedback on the system itself. I say easy, we do need to work with the prosthetist and the amputee to get that custom device, but it's fairly easy beyond that to get some feedback on our prosthesis, which is very, very helpful.
What has that feedback looked like? Like, have you guys learned anything super interesting?
Yeah, we learn interesting things all the time. And it's amazing because the more feedback you get, the more data points you have, the more you can say, okay, I think that's maybe just that person's opinion versus sort of something that keeps coming up over and over. And so there's, the amount of adjustment that the patient can make on their own, or the location of certain dials or the size of certain dials. That seems to be things that people will debate on or give different feedback on. And then the more and more feedback we get, the more there seems to be a consensus, and we can kind of go with one of those. So one of the ways that we're using the feedback now is to inform where future generations of the product are going to go. So what features should we be including, or what are the top priorities for future products? Because obviously there are things we'd love to be including as we go, and asking clinicians and amputees now is a really great way to inform that kind of change.
Yeah, I think that really is an example of like user-centered design. So that's awesome to see. I wanted to ask, so you've obviously done a lot of pitching over the years. What is a story that you usually tell investors, and what is their biggest pushback?
Ooh, those are good questions. I usually tell the shoe story. So we've all worn shoes that don't fit, and we've all gotten blisters. And I find that that really helps investors, especially those that have never met an amputee or don't know someone with an amputation or don't have lived experience with amputation. It helps them connect to the problem and understand just how frustrating and debilitating this truly is. The biggest pushback that we get is around the size of the market and the lack of digitization. And so for the lack of digitization, as we've spoken about, it's more about access. And especially for our first product, we want it to be as accessible as possible. Not to say we can't include, digital sensors and electronics in future versions. We're definitely open to that, but it's just not something we felt we needed in this first version. And then in terms of the market size, I think people can, especially if you've never met an amputee, it's like, oh, well, I mean, it's not that big a problem. But, there's 185,000 new amputations every year in the US alone. And that number is only increasing with the increasing rates of diabetes, the aging population, and then global conflict that's happening around the world. So unfortunately, this is a large issue and a growing issue.
What's your beachhead market within lower limb amputees?
So when we're looking at the market in the US, it's about $2 billion, $1 billion annually when you account for amputees' eligibility for their first prosthesis and the frequency with which they get a new one. And so we're starting our sales in the US. There's existing reimbursement there. There's a lot of existing sales channels that we can sell through. And so we'll start there and then expand back home to Canada and over to Europe as well.
This is a question I always had. Like, do you do the top-down approach to market sizing, or is it the bottom-up approach? Like, which is better? But ultimately, there's a lot of numbers.
So many numbers. You should see the spreadsheets of different ways that we've calculated this. I think at the end of the day, you're really trying to justify the need for your product, which I think is easy when you have something that is so needed. And you're trying to get a general sense of how big the numbers are. Because as you said, depending on how you calculate it, it's going to drastically change the numbers themselves. And there's no one way that you can calculate a market size. I really, 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 really wish there was, but there isn't. And so for us, when we're looking at it, we try and do a bunch of different versions of the calculation using different published numbers so that we can see how sensitive the numbers are and then what that opportunity truly looks like. And I think at the end of the day, when there's other companies that are selling into those markets and are quite successful at it, you know that the market is there and is sustainable and is growing.
Yeah, I think that's a really good validation point. I think earlier in my journey as an engineer and innovator entrepreneur, I felt like, oh, if someone else is already doing it, like, why would I do it too? But actually, if someone else is already doing it, if an incumbent in the space is already doing it, that's your biggest validation that someone is going to put money on this problem.
Absolutely. And even if they're doing something complementary to you, right? Like we look at different companies that are selling ankle components or knee components or attachment components. So of course there is a market for this because these companies are doing quite well selling to this population. So if we share the same patient population that we're going after and we're just focused on different elements of the problem, I think that's a really sustainable way to grow within the industry as well.
So you talked earlier about Techstars, and I know you guys have been through other accelerators. What did these ecosystems give you that helped you accelerate the progress of Vessel?
I love quotes. And one of my favorite quotes is learn from the mistakes of others because you can't live long enough to make them all yourself. And in startups, it's learn from the mistakes of others because your company can't live long enough for you to make them all yourself. And so for us, it was twofold in terms of, it always came down to the network. And it was a network of fellow founders who have also been there, done that, or are currently being there doing that with you that you can bounce ideas off of and learn from. There are strategic advisors and mentors who you can work with who can literally accelerate you. That's why they're called accelerators, and say, hey, I have experience developing pricing strategies for startup companies and large companies in medtech. I can guide you on how to create your own pricing strategy. As luck would have it, not something I learned in engineering. So to have someone guide you along that pathway is extremely valuable. And then the third part of the network is investors, customers, etc. And so by expanding your network in some of these accelerator and incubator programs, you're able to access all three of these kind of categories of individuals that accelerate your progress.
Okay, very cool. This is the most important question. Did you like your time in Texas?
Well, that's such a good question. I loved it. I loved it. I was in Dallas, Fort Worth. So
Hmm.
I was on the Fort Worth side, kind of near Magnolia Street, and it had recently been gentrified. I don't know, someone told me that. And so there were all these like beautiful little cafes and restaurants. And I swear I actually did work at Techstars, but it was also just such a fun experience. And then coming from Canada, it was so warm. I was there from like September to December. It was beautiful. It's like, this is fantastic. This is when it gets cold and crummy in Canada. So that was really nice. And everyone could pick out my accent within the first like 3 sentences, which I found hilarious because I swear I do not have one until I chat with people from the South, and then they can pick it out.
I heard it right there on the
Yeah.
on the out.
Yeah, exactly. As soon as that was always the word that gave me away, and I could never hear it. People would be like, "You say out funny." I'm like, really? Like you say it, and we would go back and forth. I'm like, I don't hear a difference, but I can. Since living in Texas, I do hear the difference between out and out.
Yeah. Yeah, I'm from Dallas, so I was just curious.
There you go. So you would know.
Yeah. So originally you started out as kind of more on the technical side, is that safe to say? And
Yes.
now you've evolved to more of the executive side and the business side of things as CEO. What did that evolution look like? What were hard skills to pick up as an engineer? Like, what were those learning moments and what did that growth look like?
That's a great question. I would say that the transition was abrupt and intentional. I am an engineer by training, but not by passion. So figuring out the physical problems with the device is just not how my brain works. I have zero interest. I didn't realize until we started trying to prototype for this, and I went, whoa. No, thank you. My co-founder's great at it. That's the way his brain works. He loves it. He's good at it. We called him Tinkerbell early on because he would tinker with everything. Like he's just good at that stuff. And I am not. And so it was an abrupt switch, a very intentional switch. And I would say that the good things that engineering gave me was the language to talk about engineering problems. So I feel as though I can successfully communicate with our engineering team and our clinical advisors, and I can translate between the two groups rather effectively. So that is a useful skill that engineering taught me. Problem solving in general, everybody talks about how engineering teaches you problem solving skills. So I can apply those to any other facet of the business rather successfully, which is great. Some of the skills that I needed to learn when I came into the CEO role was very much public speaking. It's something that I've always been fairly comfortable with. I did theater as a kid, like a young kid, but I still did it. So getting up in front of crowds of people was not something I was nervous about. But being able to articulate your story in a succinct way is a skill. And that was something I really needed to learn. And then I needed to learn everything about business. So anything that had to do with sales and marketing and all of it, I had to learn. And luckily now we're at a point where I can bring on people who have that background instead of me, either to augment my skill set, to be an advisor, to be a teammate, which has been really, really helpful as well.
Okay. Yeah, it's really interesting to hear that art because I feel like for me, it was the same way. Like learning all these business skills was like, whoa, but definitely a very cool skill set to have and obviously very essential to the company.
Absolutely. And very translatable to different areas. And I would say none of it was something that, not trying to bash business school in any way, but not something that I found too onerous to overcome. I think all of the skills were things that if I watched enough videos and read enough books and listened to enough advisors and worked with enough smart people, it was something that I could pick up rather quickly. And maybe that was just something I was passionate about, but I definitely appreciate working on the business side,
I think this is a theme that I see come up with a lot of founders is the self-learning, especially when it's hard or discouraging.
which it often is.
When you look 5 to 10 years down the line, how do you think prosthetic care looks like with technologies like Vessel?
I think that prosthetic care is going to get more and more user centric. There has been historically not very much data in prosthetics, and that's because it's very difficult to obtain data from people that have leg amputations or arm amputations. And so, with now different sensors that can be embedded into different systems, and with the increasing use of things like microprocessor knees and electronic ankles, these types of technologies, I think we're going to get a lot more data into the prosthetic industry, which can then really inform what the future devices are going to look like. I think before it was, my mom has an amputation, she would have benefited from this technology, so therefore everybody wants this technology. And maybe that's not always true. Whereas now we can start to get, especially with some of these clinics that are large clinic organizations and have 20 or 100 or several hundred locations, they can take all of this data from all of their different clinic networks or clinic locations, synthesize that data, and use that to inform what the next products could be or could look like. So I think that in future, prosthetics is going to become even more user centric, and the next devices are going to be things that maybe we didn't realize we needed, but will make a huge difference in the lives of patients and prosthetists.
All right. What does the future of the kin system look like? Do you see a system where it can autonomously adjust up and down in size for different amounts of fluid that are accumulating in the leg throughout the day?
Absolutely. I think that, expansion and contraction, both automatic, would be fantastic. There's a lot of other integrations we would love to do. There's different components that make up a prosthetic leg. And if you can integrate multiple of those components into one, that saves a lot on height, that saves a lot on weight. So not only making our system as small and light as possible, but just integrating it with some of the other systems you have to use anyways, that kind of has the same effect of decreasing overall height and weight. So there's different elements like that. There's different features we can add. This one is shock absorbing, but what if we added torque absorption? There's all these different ways that we can take the device, and we're really excited to be able to do that.
Sydney, thank you for sharing your journey. I really appreciate it.
Absolutely, Ivan. Thank you so much for having me. This was a really fun conversation.